All right, so now that we've talked about finding solutions to linear equations, the next thing that we want to talk about is graphing linear equations. There are several methods for this, and the first one that we are going to look at is graphing using a table. This comes from section 3.1. So in order to do this, you want to know how to find points or solutions of a given equation, and you also want to know how to plot and label the points. This is basically the previous two sections that we looked at. Upon completing this presentation, you will be able to create a table of points that are solutions to an equation. You will be able to identify good numbers to plug into an equation, and you will be able to graph a linear equation by creating a table of points. Okay, so our procedure in order to graph linear equations using tables, the first thing we want to do is find at least 2 points that are solutions to the equation. Remember, in order to do this, what we want to do is pick at least 2 numbers, plug it into our equation to find both coordinates. From there, we want to plot the ordered pairs in the rectangular coordinate system. And assuming we have done everything correctly, we are going to have a line that we can draw through the points. Finally, we want to label the points with their ordered pair names, and we're done. Now, a couple things to note. Many students struggle with this method because of the freedom associated with it. You can pick any numbers to plug in, but some numbers are better than others. It is recommended that you pick numbers that are small so that you are near the origin and axes. By small, I'm going to say do not venture any further beyond -5 or +5. If you have a fractional coefficient, you should pick numbers that will cancel with the denominator, i.e. numbers that are multiples of the denominator, so that the denominator cancels out and the points are easy to plot. Okay, so let's look at some examples here. We want to create a table of values for each of the equations, and in this section I'm going to recommend that we find 3 points. We're going to graph the equation, and we do want to label at least 2 of them on the graph. So let's start off by creating our table for example A. Example A, I want to pick 3 numbers to plug in. Me personally, when I have the freedom to choose, I go with -1, 0, and 1. These ones are easiest only because it's easy to multiply by 1, therefore it's easy to multiply by -1. It's also easy to multiply by 0. So if we go ahead and plug these into our equation, we get, for the first one, y equals 2 times -1 minus 1. That will result in 2 times -1 is -2, minus 1 gives me -3. So when x is -1, y is -3. Let's repeat the process for 0. We have y equals 2 times 0 minus 1. 2 times 0 cancels, and I am left with -1. And finally, if we plug in 1, we get y equals 2. Replace x with 1 minus 1. 2 times 1 is 2, minus 1 is equal to +1. And so my y-coordinates, my corresponding y-coordinates, are -3, -1, and +1. So from here, I want to go ahead and graph this. So I'm going to start by plotting my points. So if you want, you can write them in point form, or you can go ahead and just plot them as it is. Remember, we are still going to have to label them once we do our graph. So remember that we have the point -1, 3, x, comma, y. The x tells me I want to move 1 left. The y tells me I want to move 3 down. So if we do that from our graph, starting at the origin, we move 1 left and 3 down. We should end up right here. For the second point, we have 0, -1. Remember that since x is 0, that means I do not move left or right, and I want to move 1 unit down. So from the origin, I'm going to go 1 unit down, and I will be at -1 on the y-axis. So there's our second point. Now, this is all you really need in order to graph the equation, but the third point is kind of a checkpoint. We have 1, 1, which tells me I want to go 1 to the right and 1 up, and plot my point there. Now, assuming you did everything right, notice that we do get kind of a linear look to this, and now all I have to do is draw my line through these 3 points. So if I draw my line, it will look something like this. Man, this is a lot easier than doing it on the board, which you will see in class probably. So our last step is we want to label. So my points are -1, -3, 0, -1, and 1, 1. And we're done. All right, so now let's go ahead and look at example B. Example B, I want to do the same thing. I want to create a table of values. So I'm going to use the same numbers again because they are, as I said, the easiest ones to work with. So I'm going to plug in -1, 0, and 1. So if we do this, we get y equals 3 times -1, which is -3. So when x is -1, y is -3. If we plug in 0, we get y equals 3 times 0, and 3 times 0 is 0. So when x is 0, y is 0. And finally, we have when x is 1, we plug it in, replace x with 1. We get 3 times 1 is 3. And so when x is 1, y is 3. So now if we go ahead and plot these points, we get -1, -3 is going to be left 1, down 3, so right around here. Zero, 0 is at the origin, and 1, 3, we want to go 1 to the right and 3 up. So our final point should be somewhere right here. Finally, or next step, we want to draw a line through our points. And it should look something like this. We want to label. So we had -1, -3, 0, 0, and 1, 3. And we are done with our graphing of these 2 examples. Hopefully you find this pretty easy. Again, the hardest part about this is just picking what numbers you want to plug in. The numbers that I selected, are they the only ones that you can plug in? No. If you don't like working with negatives, you could have worked with 2 instead. But I do recommend making sure that you do keep your numbers as close to the y-axis as possible so that you don't get too large. For instance, if we worked with 2, we're going to be getting to 3 times 2 is 6. That one I have room on my graph. But if I go out to x equals 3, now I'm looking at y equals 9. And the further away that you venture from the y-axis, then the harder it becomes in order to graph them accurately. So let's look at a couple more examples. If we look at example C, again, me personally, I'm going to start with my same numbers again. I want to plug in x equals -1, 0, and 1. If we plug in -1, we get y equals -2 times -1 minus 2. -2 times -1 is +2. Minus 2 gives me 0. So when x is -1, y is 0. If we plug in 0, we get y equals -2 times 0 minus 2. Our -2 times 0 cancels, and we are just left with -2. So when x is 0, y is -2. And for our last example, we have y equals -2. We're going to plug in 1 for x. We get -2 times 1 minus 2. This is equal to -2 times 1 is -2 minus 2. We want to add and keep the sign because they have same signs, and we get -4. Okay, so now let's go ahead and graph this. If we go ahead and graph this, we're going to start with our first point, which is -1, 0. So remember, this tells me to go 1 to the left, do not go up and down. So -1, 0 is on the x-axis right here. For our second point, 0, -2, we have that we are going to start at 0. We do not want to go left or right. We're going to go 2 down. And so if we go ahead and graph that, we will be right here. And finally, our last point, 1, -4, we want to go 1 to the right and 4 down. And so we should end up in the fourth quadrant right here. We want to draw a line through our points. And we want to label. So we get -1, 0, 0, -2, 1, -4. Okay, that takes care of example A, or C, example C. Let's look at one more together. Let's look at y equals 2/3 x plus 1. So this one of the important things to keep in mind here is that this one has a fraction for my coefficient. And whenever I have a fraction for a coefficient, I don't go with my typical values of -1, 0, and 1. Only because if I multiply by anything other than 0, The negative 1, I'm going to end up with fractions. Same thing with positive 1. I'm going to end up with fractions. And part of the problem is, 1, working with the fractions, because that is always a tricky spot for us. And 2, more importantly, can you graph them accurately? Probably not. And remember that we do want to graph this accurately, and we want to make it as easy as possible. So for something like this, instead of picking my negative 1, 0, and 1, what I'm going to instead choose to work with is multiples of the denominator. Now, if you're okay with your negative numbers, then you can go ahead and use negative 3, 0, and 3. These are also going to be the most basic ones to work with. So from here, we want to go ahead and plug in these numbers and see what we get. So for the first one, we get y equals 2 over 3 times negative 3 plus 1. Here, my 3 and my negative 3 cancel out, leaving me with 2 times negative 1 plus 1. 2 times negative 1 is negative 2 plus 1 equals negative 1. We have different signs. We're going to subtract, keep the sign of the larger number. So when x is negative 3, y is negative 1. Okay, let's repeat the process with 0. If we plug in 0, we get 2/3 times 0 plus 1. Well, anything times 0 is 0. It cancels. And so we are just left with positive 1. And for our final problem, or our final x value, we have y equals 2/3 times positive 3 plus 1. This is equal to, our 3's cancel, leaving us with 2 times 1, which is 2, plus 1 is equal to 3. So when x equals 3, y equals 3. Okay, let's go ahead and plot these. If we plot them, we end up with the first point, negative 3, negative 1. I want to go 3 to the left and 1 down. So 3 to the left, 1 down will be right here. We plot our point. Next one, 0, 1. Remember that we have our x value is 0, so I'm not going to go left or right, but I am going to go 1 up. So when we plot this, we get 0, 1 is right here. And for our last one, we have 3, 3. So this tells me I want to go to the right 3 and up 3. If we do that, we get 3, 3 is right about here. Okay, so now finally we want to draw a line through this. It should look roughly like this. And we want to label. We said negative 3, negative 1, 0, 1, and 3, 3. And that will be our final answer. Now, one of the reasons, as I said, that I like to do 3 points on these is, for instance, if we make a mistake. I'm going to graph it on here, so hopefully it will kind of still look okay. So if we go ahead and let's say that we put, instead of 0, 1, when we graphed it, we put it on the x-axis. If I try to draw a line through this, I don't know about you, but I can't really quite get a line through it. It's always going to curve somewhere. And so the purple line, this would be a bad line to draw. So we want to stick with the blue one, but as I said, the purple, the reason that we want to go with 3 points is to kind of do a checkpoint and make sure that it is actually a line that we are drawing. So hopefully that makes a little bit more sense in terms of what we're doing. Let me go ahead and erase the bad one and put the good one back out here. And this takes care of graphing using tables. Hopefully it makes a little bit of sense. Again, this is a method that some students do struggle with, but in terms of graphing, it's not that bad. You just have to start by finding good numbers to plug in. Okay, so when will we see this again? Graphing using a table is the most basic form of graphing. It works for any type of equation, whereas other methods are specific to the type of equation that you are trying to graph. So that is one of the main things that we want to keep in mind is graphing using a table. It doesn't matter what kind of equation it is. It can be square root, it can be rational, it can be parabola, it can be cubic. And you may be sitting here thinking, what is that? Doesn't matter, you'll see those in future math classes. But the most basic form of graphing is using a table, and this works across the board. Okay, so that's where you will see this again. So now finally, try the following problems on your own, bring them to class, as well as any questions that you may have, so that we may go ahead and review them. Please take a minute to pause this as you work on these problems. Once you have finished working on these problems, then go ahead and unpause the program to go to the next slide. As part of your notes, please answer the following questions and bring to class along with the problems from the previous slide. How confident are you with the material presented in this section? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?